Hello Carolina Con, welcome aboard at my talk. My talk is called Fuzzing, Finding Your Own Bugs in 0 Days. My name is Rodolpho Concurde, but you can call me by my nickname ROd0X. A little about me. I'm implementation tester, instructor of IT, consultant of information security throughout 30 years. I'm certified ethical hacker by the Council. I already gave talks at Hacking the Box, Eco Party, Arab Security Conference, Mortar Relucon, Reddit Team Village, StackConf, besides Athens, besides attacks, etc. I'm author at Hack9 magazine about Stack Overflow and Pentest magazine about the cover channel from Fuzzing to get a shell, from SCA to overwrite to get a shell. I leave here my LinkedIn profile and my email for who wants to take out some doubts with me. You can write me and I'll take out your doubts. Our agenda. We will learn about fuzzing. We will learn types of targets, type of attacks, types of fuzzers, buffer overflow. Do we have a POC? Types of targets might be protocol, application, file format. Protocol, FTP, POP2, SMTP, Telnet, anyone, any protocol. Application, any input of any application. File format, any file format, MP3, M2U, MP4 for test software readers. Types of attacks. Fuzzers would try combinations of attacks on numbers, shards, metadata, pure binary sequence. Is sent for the target one list with sequence of dangerous string. Again, is sent for the target one list with sequence of dangerous string. And here we have some examples of dangerous strings. Types of fuzzers might be dumb smart fuzzing, dumb, any string combination, smart fuzzing. Smart fuzzers are programmed with knowledge of the input format, a protocol definition, or rules for a file format. Smart fuzzers might be mutations, generations, or evolutionary. Smart fuzzers is a complex subject and they deal our zero time with this talk. I want to get in depth with this subject about smart fuzzing, but I leave here a link of InfoSec Institute and Imperva with more information about smart fuzzing. Here we have more information about smart fuzzing, information about mutations, generations, evolutionary. For who want to read more about smart fuzzing later. Buffer Overflow. Buffer Overflow is an anomaly where a program, while writing data to a buffer, overruns the buffer's boundaries and overwrites adjacent memory locations. Might be RIP-based and stack-based. RIP-based. Place in the memory which locate a lot amount of data and dynamically. Stack-based. Allocate a limited or fixed size of data, such as data from local variables or functions. Here we have a buffer overflow code example. In this code example, we have buffers, shards with size 5 size bytes. Well, what's problem with this code? This problem is that this code don't verify what it should do if you use insert more than 5 bytes. Then, if you use insert more than 5 bytes, this software will get a crash due a stack overflow. Again, this code buffer char 5 bytes. Don't verify what should you do if you use insert more than 5 bytes. So if you use insert more than 5 bytes, this software will get a crash due a stack overflow, due a overflow in stack. Here we have an image of stack overflow. We have a right image and the left image. In right image we have 150 A's. In the left images we have 11 A's. As we can see, we have in right images a lot amount of character A's. This character A's overwrite the register ISP, and the register EBP. The character A overwrites the register ISP and the register EBP. So occur here a stack overflow. Overflow in the stack, as we can see in this image, right image, we have here a overflow in stack. Now we have a POC. Discover input format to realize the fuzz. Example of the protocol POP3. Here we have a Python script of fuzzing. Here we have a variable buffer with equals character A, color equals 100, color equals color plus 200, and we have here connect IP against the port 110. And we have here come the user, come the path. What the code, this script will do? This script you send the command user, command path. In the command path we have plus string, and we have here string in buffer, and the buffer equals A. So you will send in command path a lot amount of character A. So again, we'll send in command path, a lot amount of character A. This command user command path is specified in this document RFC 1081. This document RFC 1081 is document for protocol POP3. Each protocol has your own document. Each protocol uses your own command. Again, each protocol uses your own command. In this case of protocol POP3 make use of command path. And in our script, we will send the command path plus string, we will send the command path a lot amount of character A, because path plus string in buffer, buffers equal A. We will send the command path a lot amount of character A. Here we have a vulnerable software to download. We have a link of vulnerable software to download. Let's see the video POC. Let's see the video POC. Let's run the nmap against the target IP. We have a port 110. as open. Here we have a fuzzing Python script, buffer equals a, color equals 100 for string in buffer. You send command the user, command the pass, in command the pass you send string in buffer, buffer equals a against the target IP port 110. So we will send a lot amount of character A in command the pass against the target IP port 110. Let's run the Python fuzzing script. And now let's run the nmap port scanner again. And as we can see, the port 110 is down. The port 110 is down. So work the Python fuzzing script. So now we will use this vulnerable software. Here we have a link of ASX to MP3 converter. This is a vulnerable software that we will use in the next POC. Let's see the next POC. I'll explain step by step. In this POC, we will learn how to write your own exploit code for get a shell in vulnerable software, get a reverse shell in vulnerable software. Let's open the exploit code. We have variable buffer size 50,000, my buffer. We have a lot amount of characters. We will send against the target this a lot amount of characters. This a lot amount of characters was generated by two pattern create. We will send against the target against the vulnerable software. We will load in vulnerable software. It's a lot amount of character that was generated by two pattern create. Let's use a two pattern create. Pattern create -l the length 50,000. Let's copy this a lot amount of characters and paste in our exploit code. And paste in our exploit code. Let's save our exploit code. Let's compile our exploit code. Exploit code in Perl. So let's move our compiled exploit code to a desktop, to the desktop. And let's copy the compiled exploit code to a victim VM. Let's open the Munity debugger and let's start the vulnerable software. Let's attach the vulnerable software file, attach the vulnerable software in Munity debugger. The software is paused. Let's click in button run. Let's load the compiled exploit code in our vulnerable software. Then we get a crash, we get a stack overflow. As we can see, we have register ISP, we have in register ISP our overflow, our lot amount of characters. We have here a stack overflow. Now we're using a parent offset to find the offset of the register EIP. Parent offset -L the link 50,000-key 79533579. So let's understand what's the function of register EIP. The register EIP has the function indicate the next address that the processor, the CPU, will execute. Again, the register EIP has the function indicate the next address that the processor, our CPU, will execute. So now we need to find the offset of register EIP. Register EIP indicates the next address that the next address that the CPU will execute. We found the offset 35,056. Let's open our exploit code. Let's open our exploit code. We have a variable buff size 50,000, variable junk x41. X41 means character A multiplied by 35,056. So this indicates that we will fill up 35,056 with character A. We will fill with character A up 35,056. And now here we have a variable EIP with jump ISP. So now we need to get a control of register EIP. We found the offset of register EIP because we need to get a control of register EIP. In register EIP, we will put an expression, an address. We put an address that make jump ISP. For make a jump from EIP to ISP, in ISP we will put our shell code to get a reverse shell. So again, we get a control of register EIP. Register EIP indicates the next address that the CPU will execute. We get a control register EIP. We will put a address in register EIP, address that make jump ISP. For make a jump from YIP to ISP. In ISP, we put our shell code to get reverse shell. Let's type in command bar exclamation mona modules. Exclamation mona modules. We need to find a module with secure mechanism as false. Safe SE8, ASLR, NX complete as false. We need to find a module with secure mechanism as false. And we found and we use a module msvols.dll. We use a module msvols.dll. This module has secure mechanisms as false. Now let's use a tool NASM shell for find opcode for jump ISP. Type in Metasploit framework tools exploit NASM shell jump ISP. Type in NASM shell jump ISP. For find opcode for jump ISP. Because we need to find, we found the opcode FFE4. FFE4 is opcode for jump ISP. Because we need to find the address for jump ISP inside of module msvols.dll. So let's type in command bar exclamation mona find exclamation mona find dash s search FFE4 search jump ISP. That means FFE4 means jump ISP inside the module msvols.dll. And we found our address 01BA13 5B. 01BA13 5B is our address inside the msvols.dll. Our address that it has opcode FFE4. FFE4 means jump ISP. We found a jump ISP inside the module msvols.dll. We found the jump ISP FFE4 inside the module msvols.dll. And we type variable YIP 5B13BA01. 5B13BA01 is an address that make jump ISP. It's an address that make jump ISP. Now we put some values that are very shards. We will load your vulnerable software all these values from 01, 02, 03, 04, 05, etc. up FF inside of vulnerable software for see if it occurs some error. Let's understand better in our slide. Let's understand better what it means bad shards. Now we need to search for bad characters. Depending on the applications, type of vulnerability, and the protocols used, maybe certain characters which are considered bad and should not be used in your buffer or shellcode. One example of the bad characters is a 00. This character is considered bad because a null byte is also used to terminate a string copy operation, which would truncate our buffer whenever the null byte appears. So, has some characters that are considered bad for our software. For find these characters that are considered bad, we will load in our vulnerable software all these characters from 01 up FF for see if occurs some error. If occurs some error, that means that exist some bad characters. And we need to avoid bad characters when we will generate our shell code. we need to avoid our bad characters when we will generate our shell code. For don't occur error in execution of our shell code. For this, we will send all these characters from 01 up FF against the vulnerable software for see if occurs some error. Remember, we already know that 00 is a bad character. For this, we won't send the 00 because we already know that 00 is a bad character. So we have here variable exploit junk concatenated with IP concatenated with bad shards. Let's compile our exploit code. And move the compiled exploit code to a desktop. Let's restart the Munere debugger. And click in button run to run the vulnerable software in Munere debugger again. Let's copy our compiled exploit code to a victim VM. Right button, go to expression, and put a breakpoint in 01BA135B. Put a breakpoint in 01BA135B. And we have here jump ISP. FFE4 is our opcode for jump ISP. Let's put a breakpoint in jump ISP to stop the flow of execution in jump ISP. Make a double click in jump ISP. Make a double click in jump ISP to put a breakpoint jump ISP to stop the flow of execution jump ISP. And load our compiled exploit code in vulnerable software. And we have flow of execution stopped in 01BA135B. As we can see in register IP, we have 01BA135B, 01BA135B. In register IP. Right button register ISP following dump. Let's see the content in dump content in register ISP. We have here 01, 02, 03, 04, 05, 06, 07, 08, and we don't have 09, 08, 0B, 0C, 0D, 0E, 0F, etc. We have here some error because after 08 we have 000000 we have here some error because we have some bad characters inside in the middle of these values. We have here some bad characters because after 08 we don't have 09, 08, 0B, 0C and etc. We have some bad characters here. I already know that our bad characters is a 0A. So let's erase our character 0A. 0A is our bad characters. So we have two bad characters. 00 and 0A. 00 and 0A. 00 and 0A is a bad characters. Let's save our exploit code and compile our exploit code again. Let's move our compiled exploit code to a desktop. Restart the Munity debugger. Click button run. Right button, go to expression, find address for jump ISP 01BA13 5B, is add for jump ISP, make a double click in jump ISP to put a breakpoint in jump ISP. Let's copy our compiled exploit code to a victim VM. And load our compiled exploit code in vulnerable software. And the flow of execution stopped in 01BA13 5B register EIP. Let's click right button register ISP, following dump. And now as we can see, we have here in register ISP 01, 02, 03, 04, 05, 06, 07, 08. And after 08, 09, 0B, 0C, 0D, 0E, 0F, 10, 11, 12, 13, and etc. We have all the values, all the characters here. We don't have more error because the bad characters that was generating error was a 0A. Now we don't have more error because now we are avoiding a bad character 0A. Let's restart the Munity debugger. Now we already know that bad characters is 00 and 0A. Click button run. Now let's generate our payload, generate our shell code, avoiding a 00 and 0A. Right button, go to expression, find the 01BA13 5B address, put a breakpoint in jump ISP address. Double click in FF4, double click in FF4 to put a breakpoint in jump ISP. Let's see our IP for make a reverse shell. Let's use a 2 MSF Venom. Let's use a 2 MSF Venom for generate our payload. Generate our payload to create a reverse shell. let's type msf vino -p of payload Windows shell reverse TCP any host local IP any port to get a connected back in port 555 F file per -e encode shikataganai bed -b avoid bad character 0800. Again, payload shell reverse TCP and host local IP port 5555-F file per -e encode shikataganai -b avoid the bad characters 0800. So we have here our exploit code buff size 50,000 junk variable junk x41 character A multiplied by 3556 to get the control of register IP. Register IP with address 5B13BA01 is an address to make a jump ISP. Some loops x90 multiplied by 10. Here we have some loops. Loops means no operations because do nothing. When the process of execution passes in loops, the CPU will do nothing. Because loops means no operations because do nothing. And after the process passes in loops, will arrive in shell and execute our reverse shell to get the connect back. So let's erase our old shell code and paste here our new shell code. Let's paste here our new shell code. Again, loops means no operation because do nothing. The flow of process will pass in loops and will do nothing, and after will execute our shell code to make a reverse shell for we get a connect back. Paste our new shell code. Here we have variable exploit equals junk concatenated with IP, concatenated with loops, concatenated with shell. So let's save our exploit code. Save our exploit code. Compile our exploit code per name of exploit code. We have a POC file. Let's move our POC file to a desktop. Now let's put a netcache to listen on port 5555 to get a connect back in port 5555. Let's copy our compiled exploit code POC file to a victim VM. And let's load our compiled exploit code POC file in our vulnerable software. Flow of execution stops 01BA13 Let's click right button register ISP following dumping. And as we can see, we have here our loops 90, 90, 90, 90, our noobs, and after our noobs we have here BA B097. We have here BA B097. D4 is our shell code. We have here our shell code. To make a reverse shell, we have here our shell code. Let's click in button run to continue flow of execution, and we get a reverse shell. We got a reverse shell. Let's see the IP config. Here we have IP of victim VM. Let's use a user ROd0X and administrator. User ROd0X and administrator. Is it, everyone? We got a reverse shell. So, is it? We have here in these slides step by step of how you can write your own exploit code, how you can find your new vulnerability, bugs, and 0 days through of Python script, as I show in the first epoch, and in the second epoch we learned how you can write your own exploit code. We have in this slide step by step of how you can write your own exploit code. Is it, everyone? Now I open for the question. Thank you so much.